rate of the reaction, and then we will discuss little bit about the rate of reaction in terms of a change in a concentration of either of the reactant or a product with the time. And then we will start discussing between the elementary and complex reaction, and differentiate between the molecularity and order of reaction. Then we will define a rate constant and discuss little bit about the dependence of rate of reaction on concentration, temperature, and catalyst. And the last part of this portion is that to determine the rate constant for the zeroth first order reactions and describe a collision theory. So this is just a overlook of this chapter, that what we are going to study. So you can see the next slide. Uh, okay, just a minute. Right. So the basic questions in front of all of us is what? That why do we need to study a chemical kinetics? So in this plot, I have mentioned several figures. So here it represents a engine of a car, right? So we know that different cars can operate on the different engines, which can be for the petrol, or which can work on the diesel, or which can work on the LPG. And this working principle of the engine depends upon that how the rate of burning of these different fuels, whether it is a petrol, diesel, or LPG. So depending upon their rate of burning, the principle of working of an engine can differ. So it's always good to know that how the rate of burning of this of particular fuels can work on this engine principle, so we can design a new engine for the different purpose, right? The second example I have mentioned over here is the tomato. We know that in a summer season the tomato gets spoiled very fast. The question should arise in our mind that why it is so. In a summer season it is getting spoiled very fast. The reason is that the rate of spoiling of this tomato increases very fast due to the increase in a temperature, and we know that rate of reaction is dependent upon the temperatures. So it's a really very important to understand that how a rate is related with the temperature, so that we can monitor or control the rate of reaction. Here we can control the rate of spoiling of the tomato if we are going to decrease the temperature by using the refrigerator, right? So another example over here, the most of the pharmaceutical industries uses this chemical environmental for that at what rate that particular drug is acting or it is a functioning. So it's a really very important to understand the basic principle behind the chemical kinetics, right? And we know that many monuments are we need to know the age of the particular monuments. That we can do with the help of the carbon 14 decay. If we know the half life period of these monuments, we can definitely find out what is the age of the particular monument that has been made, right? So overall on this slides I want to discuss that the chemical kinetics, this chapter is really very important in every respect and every aspect of the scientific community. So it's always important to understand what is the chemical kinetics and how the rate can be differ and what are the different factors that can affect the speed of chemical reactions. So now in the next slides we will talk about how to calculate the rate of reactions and what are the different factors that can affect the chemical reaction. Okay, in this slide, just see the rate of chemical reactions. For calculating the rate of chemical reaction, we will just consider a hypothetical reactions. Let R be the reactant and P be your product. Right. So this is a very simple chemical reaction I have mentioned here. So if I need to calculate the rate of this chemical reaction, let us assume that my reaction has been started at initial time of T1 and it is getting completed, the product formation is getting completed in a time T2, right? So whatever the change in a concentration of a reactant, R1 represent the concentration of the reactant at a time T1 and R2 represents the concentration of the reactant at a time T2. So the overall change in a concentration during the reaction will be represented by the delta R symbol. Similarly, the change in a concentration of the product can be given by P2 minus P1, where P2 represent the product concentration at a time T2 and product concentration at a time T1. So there are a very important factor what is called as a instantaneous rate and average rates. So how to calculate this instantaneous rate and average rate, that we are going to see in the next slide. So in these slides, you can clearly see that the reaction, if I'm considering R is forming a product P, right? This is the simple reaction what we have studied in the last previous slides. So R is forming a product P. This is a hypothetical reactions. So you can write the rate of any chemical reactions either in terms of the reactant, and I have written over here the rate of disappearance of a R. Disappearance means what? R, whenever the reaction has been started, the concentration of a R will keep on decreasing and product concentration will keep on increasing. So basically this reactant concentration is a disappearing during the reactions. So while writing the rate of chemical reaction in terms of a reactant, you always write it down rate of disappearance of R, because R concentration of R is keep on decreasing during the reaction. So it is always equal to decrease in a concentration of R upon a time taken, whatever the time, whether it is 30 minutes or 20 minutes taken for the given reactions, that particular time will be over here, right? So the decrease in a concentration of R upon time t. So delta t upon R upon delta t, this is called as an average rate, because whenever the time period is a larger and the change in the concentration is a larger, whatever the rate you are calculating, that rate is considered as a average rate. Remember this thing, the average rate is the factor which has to be written for the larger change in the concentration of reactant and larger change in a time, right? So similarly, as the product formation is occurring during the chemical reactions, you can also write it down the chemical reactions in terms of a rate of appearance of a product. Because appearance, why I'm writing over here appearance, because product is going to form, it is not going to disappear, it is going to form successively, right? So the rate of appearance of a P can be written as the increase in a concentration of a P upon time taken. So it will be a plus delta P upon delta T, right? Since delta R is a negative quantity, I'm putting over here a negative sign because the rate can never be a negative quantity. See, you can compare this quantity with the speed of a car. Speed of a car can never be a negative. It can be either, the car can either be moving in a forward direction or it can move in a backward direction, but the speed of car can never be a negative quantity, it has to be a always positive. But since reactant concentration is always decreasing, I am putting a negative sign over here to make the overall quantity as a positive. This is already, we have already learned all this concept, I am just revising the thing, so you just go really very fast. So the next slide over here. So we have seen right now what is called what is called as a rate of reaction and how to write down the rate of given chemical reaction. So now rate we have understood very clearly. Now consider a very typical example: twice Fe3 plus ion plus Sn2 plus ion reacting with the and forming a twice Fe2 plus Sn4 plus ions. Now if this reaction is given to you, how to write down the rate of this particular reaction? So I can write it on the rate of particular reaction in terms of the product formation. If there is a change in the concentration of a Sn4 plus ion upon delta T, so this is the rate for this given reaction, and it can always be equivalent to half of delta Fe2 plus upon delta T. Here, since the stoichiometric coefficient on the product side of Fe2 plus ion is a 2, so always divide by the factor 1 by 2. And there is no need to write down the negative sign on if you are considering a product concentration. So the rate for the any given reactions can be written in this manner. For this particular reaction, the rate can be written in this manner. If you want to write down the rate in terms of the reactant concentration, you can write down like this. You have you are writing a half, that is a stoichiometric coefficient, so you just write down 1 by 2, then delta Fe3 plus concentration upon delta T. I'm putting a negative sign over here because the reactant concentration will be continuously decreasing. So to make this speed of reaction or a rate of reaction positive quantity, I'm putting we need to put a negative sign whenever you are writing a reactant concentration. So this is the overall rate of reaction can be written for this particular chemical reaction. Now, let us consider that this is the hypothetical reaction in which A, small a and capital A is the reactant, and small a is the your stoichiometric coefficient. Similarly, B is your reactant and small b is the stoichiometric coefficient, and these are the product quantity, right? So if this is the general chemical reaction is given to you, the rate for this reaction can be written in this manner. The rate of reaction, either you just write it down rate of disappearance of the reactants. So rate of disappearance means you need to put a negative sign over there. So can I just write down the reaction in this manner? Minus 1 by A upon delta A by delta T equals to minus 1 by B delta B by delta T. Because I have considered reactant concentration, I need to put a negative sign over here. और जो भी stoichiometric coefficient होगा आपका, that we have to take reciprocal of it, isn't it? Whatever the stoichiometric coefficient is there, we need to take reciprocal of it. This is a very important part you need to understand. Now if I want to write a rate of reaction in terms of a product concentration, can I just write it down in this manner? Rate of appearance of a product, so this will be a stoichiometric coefficient का हमको reciprocal लेना होगा 1 by C, and then change in the concentration of C upon change in a time. Similarly, for the D component, you can write down 1 by D, and D change in the concentration of a D upon whatever the time interval is there for the given reaction. So for any given reaction, the ultimate rate of reaction can be written in terms of the reactant concentration as well as in terms of a product concentration. The 2 point you have to remember over here: whenever a reactant has been involved into the rate equation, you need to put a negative sign over there. However, if a product concentration is involved into the rate law, you no need to put a negative sign over here because product concentration is always keep on increasing. So overall, this rate will be anyway it will be a positive quantity, right? Now this is all about how to write down the rate for the given chemical reaction. Now, can I just equate all these equations? So, or you can always equate all these four equations, whether it is a reactant or product, all are equal. The thing is that you need to put only negative sign for the reactant, and product, it should be a positive. Now, there are different factors that can affect the chemical reactions, and you can control any chemical reactions if you understand that how this different factor can affect the particular reaction. So the first factor that can affect a chemical reaction is the nature of a reactant, right? So we know that your reactant can be ionic in nature, it can be a non-ionic, means there can be ionic compound or a covalent compound. So we know that ionic substances react very fast, so the reaction rate will be a very fast compared to the covalent substances. So basically nature of reactant definitely affect the rate of chemical reaction. The second factor is the concentration of the reactant. Of course, a rate of reaction is directly proportional to the concentration of the reactant. And if you are considering any gaseous reaction, so the gaseous reaction में क्या होगा, whatever the pressure exerted by the gaseous reactant, that will be considered as their concentration terms, right? So if you are increasing the pressure, your rate of reaction will directly, it is directly proportional to the pressure, so it will also increase. Similarly, if you are increasing the concentration, the rate will definitely increase. So concentration of the reactant has a greater effect onto the rate of chemical reaction. Now the third factor is the temperature. As I have discussed in the first slide, when we all get sick, so our body temperature keep on increasing. The reason is that our body temperature is increasing. The reason is that the rate of whatever the biological reaction that has been tremendously increased, and since the rate of reaction is increased, so body temperature will keep on increasing because they are directly proportional. Either you increase the temperature to monitor the rate of reaction or to increase the rate of reaction, or either way around, the rate of reaction is increased. What does it mean? Temperature has increased of the system, right? So the temperature has a direct effect onto the rate of reaction. The four important factor is the presence of a catalyst. We know that several biological reactions, in several biological reactions, the catalyst plays an important role. If we wanted to complete the reaction in a stipulated time, or a reaction in a very fast manner, so you just add a pinch of a catalyst into that, the reaction rate will be increases by the 10 folds. So it's always better to carry out the biological we know that the biological reaction always get in presence of a coenzymes or catalyst, coenzymes which act as a catalyst. So the presence of a catalyst increases the rate of reaction. The fourth factor, which I have mentioned several times, that is the surface area of the reactant. We know that the surface, as the surface area of the reactant increases, the rate of reaction will be a tremendously increasing, right? So the surface area, you just if you wanted to increase the rate of any chemical reaction, you just increase the surface area, the rate will be a increasing. Now, we know that several photochemical reactions, or several reactions into the nature like photosynthesis, all these reactions takes place in presence of a ultraviolet light or a sunlight. So these are the kind of radiations. So several radiations can also affect the rate of chemical reaction. So once again, I'll be repeating on this slide that these are the different factors which I have mentioned over here. This is only just for the mentioning few points, right? So there are other factor also which can affect the chemical reactions, which I have not listed over here. This is the very few important factor that can definitely affect the rate of reactions, right? So the nature of the reactant is directly proportional, means if this is the ionic compound, rate will increase. Concentration, if you are increasing the concentration, rate will definitely increase. With the increase in the temperature, rate is increasing. So you can say that rate of reaction is directly proportional to the temperature. Presence of catalyst has an effect onto the chemical reaction, that the reaction get completed in a lesser time, right? So if you increase the surface area, rate will increase. And several reactions, if you are supplying the radiations, the rate of chemical reactions increases tremendously. So these are the some factors which can affect the rate of chemical reactions. Now, a very important thing is that what is called as a rate law or a rate expression, and we are going to talk about the rate constant, which we have already studied. This is just a revision class. So we know that the expression which relates the rate of reaction to the concentration of the reactant is known as a rate law. right? So if you are relating the rate of reaction with the concentration of the reactant, that expression or mathematical equation is called as a rate law. So consider a general reaction. For example, A plus B is forming a compound C plus D, right? So the rate of this particular reaction can be written as is equals to a rate constant multiplied by the concentration of the reactant raised to the power x, and concentration of the reactant B raised to the power y. So this complete expression, rate of reaction, which is related to the concentration of the reactant multiplied by the rate constant, this complete mathematical equation is called as a rate law, right? So this rate law, from this rate law, remember that from this rate law only we can determine the order of reactions. So basically the order of reaction is what? So order of reaction, if I'm considering the general reaction, and let's say this is the rate law, this is the given. Whenever the order of reaction is asked to calculate for the given reaction, the rate expression will be provided to you. This will be given into the examination, right? So let's say for time being, this is a general reaction, and the rate of reaction is given by this expression. So order of reaction is what? Order of reaction is what? It is the simple sum of the power of the concentration of the reactant terms involved in a rate expression. So जो भी रेट एक्सप्रेशन में आपका रिएक्टेंट कॉन्सेंट्रेशन का पावर होगा, उस पावर का एडिशन आप कर दो तो आपको क्या मिलेगा? यू विल गेट अ रेट लॉ. You will get a rate law. So means you will get a order of reaction. So here the overall order of reaction will be what? Here we can say that the order of the reaction with respect to A will be x, because A का coefficient अगर मैं consider करता हूँ A, right? So this stoichiometric coefficients for the some reaction, it can be equivalent to the power x, or sometime it will be not equivalent to the power x, isn't it? So x is the order of reaction with respect to A, and y term is the order of reaction with respect to a B. And remember over here, x plus y will give you a order of this overall reaction. So x plus y is your overall order of reaction is given by x plus y, which has been involved into the this rate expression, right? Now, order of reactions, I am just enlisting few points regarding the order of reactions. So we know that the order of reactions can be a having a zero value, it can be a 1, 2, 3, any positive integer it can have, or even it can be a fraction as well. And for the some reaction like ozonolysis, or for ozone layer formation, in that particular reactions, the order of reaction is found to be a negative value as well. So overall order of reaction can occupy any value, any positive integer, any fraction, or even it can sometimes it can be a negative value. Now, depending upon the order of reaction, the reactions are termed as a zero order. We know that overall x plus y, that previous quantity what I have discussed earlier, if this x plus y, if it is happen to be a zero, that order of reaction is said to be a zero order, right? So what is the peculiar characteristics of the zero order reaction? The zero order reaction is the one which is independent of the initial concentration of the reactant, right? And first order reaction will be what? In which x plus y is always equal to 1, and if it is happen to be a x plus y is happen to be equals to 2, then it will be called as a second order reactions. So now a zero order reaction, as I said, it is independent of the concentration of the reactant, and the order of reactions cannot be a very important factor over here. The order of reactions cannot be predicted merely looking at the balanced chemical equations, isn't it? Because the order of reaction is purely एक्सपेरिमेंटल क्वांटिटी. अगर आप एक्सपेरिमेंटल क्वांटिटी से रेट कैलकुलेशंस नहीं करते हो, रेट लॉ नहीं डिटरमाइन करते हो, तो यू कैन नॉट कैलकुलेट ऑर्डर ऑफ रिएक्शंस. रिमेंबर दैट थिंग, order of any chemical reactions cannot be calculated by simply looking at a balanced chemical equations. The order of reaction has to be determined from the experiments. First you do the experiment, what is the concentration at the particular time, what is the concentration at a next time, and then you can determine the rate and you can find out the value of x and y, and then you can definitely write down the rate law or rate expression, and you can sum up the x plus y and you can calculate the order of reactions, right? Now, order of reaction and units of a rate constant. So very simple equations for a nth order reaction. Let's say A is giving you a product P. This is a general reaction I have written over here. A is forming a product P, right? So now the rate can be written for this given reaction, a rate constant into concentration of a raised to the power n. This is the rate law I have written. Consider that this is the rate law which I have determined from the experiment, right? For this particular reaction. So rate equals to k a raised to the power n. Now I need to calculate the units of a rate constant. I need to calculate the units for the rate constant. So what can I do? I will keep a rate constant on one side and I will take a rate divided by a raised to the power n. So rate divided by a raised to the power n will give you a rate constant ka unit. So now we know that a rate is always determined concentration divided by time. Rate is always given by what? रेट का यूनिट क्या होता है? रेट का यूनिट है आपका कॉन्सेंट्रेशन डिवाइडेड बाय टाइम, राइट? और ए रेज़ टू द पावर एन यानी क्या हो गया? ये इज योर concentration of reactant. So concentration of reactant raised to the power n. So can I just write down in this manner? Concentration of the reactant raised to the power n. So after simplifying this factor, the ultimate unit of the rate constant will be a concentration raised to the power 1 minus n and time raised to the power minus 1. So this is the general expression for the rate constant, or this is the unit of a rate constant. Now here I have enlisted several reactions, whether it is a zero order, first order, or a second order reactions. So for the zero order reactions, we know the unit will be a mole per liter per second, because zero order reaction में क्या होता है? The rate is independent of the initial concentration. So we know that concentration will be what? Moles per liter per second into इनिशियल कॉन्सेंट्रेशन तो मेरा जीरो है, उस पर डिपेंडेंट है ही नहीं, राइट? सो मोल पर लीटर रेस्ट टू द पावर जीरो हो जाएगा. तो आपका अल्टीमेट यूनिट ऑफ जीरो ऑर्डर रिएक्शन विल बी अ मोल पर लीटर पर सेकेंड. नाउ फर्स्ट ऑर्डर रिएक्शन में क्या होता है? आपका रेट हो गया मोल पर लीटर पर सेकेंड, ये आपका रेट का यूनिट हो गया. देन डिवाइडेड बाय क्या होता है? आपका फर्स्ट ऑर्डर में इट विल डिपेंड्स अपॉन द कॉन्सेंट्रेशन ऑफ द वन रिएक्टेंट. सो मोल्स पर लीटर should be in the reciprocal, and after simplifying this equation, the unit of rate constant will be a per second for the first order reaction. Similarly, for the second order reaction, the unit is calculated to be a mole per mole liter per second. So this is the table which mentions the units of rate constant for the different reactions of a different order. Now, along with the order of reaction, there is a very important parameter called as a molecularity of reactions. Since we have studied up till now that order of reaction is a purely experimental quantity, isn't it? So we know that order of reaction cannot be simply defined or calculated by simply looking at the balanced chemical equations. But molecularity is what? Molecularity of a reaction is a simply the number of a reacting species involved in a elementary reactions which must colloid simultaneously, or let us which must collide simultaneously, isn't it? So there is a one factor called as a elementary reactions. So elementary reactions क्या होता है हमारा? Elementary reaction is the one in which the reaction get completed in a single step. अगर आपका reaction एक single step में कंप्लीट हो रहा है, सो दैट रिएक्शन इज कॉल्ड एज अ एलिमेंटरी रिएक्शन. तो जब भी हमें मॉलिक्यूलरिटी निकालना होता है, तो मॉलिक्यूलरिटी कैन बी डिटरमाइंड फॉर द एलिमेंटरी रिएक्शंस ओनली. इट कैन नॉट बी कैलकुलेटेड फॉर a complex reaction. Now let us consider a following reactions and we will try to determine the molecularity for the given reaction. Now in the first case, NH4NO2 is undergoing a reaction to form a N2 gas plus twice H2O. Now here the reactant species में आपके पास कितना molecule है? You have only one molecule over here. So only one molecule indicates that this is a unimolecular reaction. Unimolecular means only one molecule has been reacting to form a product. Product में कितना भी हो सकता है, but reactant side में आपका कितना होना चाहिए? अगर एक molecule है आपके reactant side में, that reaction will be considered as a unimolecular reactions. Second thing, second example में क्या है? I am reacting, means there is a reaction of a twice HI molecule. Hydrogen iodide molecules in a 2 moles is reacting to form a H2 plus I2. So here molecules are reacting, two molecules of a HI is reacting to form a H2 and I2. So this is a bimolecular reactions because two molecules are reacting over here. Now in the third case, twice NO plus O2 means overall there are three molecules, two NO molecule and one O2 molecule is reacting. So this is the case of a trimolecular reactions. So in this way, by simply looking at a balanced chemical equations, you can determine the molecularity of reactions, isn't it? So the molecularity can be determined. Once again, I'm defining molecularity of the reaction is simply the number of a reacting species. Reacting species can be atoms, ions, or molecules, anything. So that should be involved in the elementary reactions and that should collide simultaneously. That is important parameter, that simultaneously collision अगर हो रहा है तो simultaneously collision में कितने molecule involved है, that number of a molecule will talks about the molecularity of given reactions. So now let us just distinguish between the order and molecularity by this distinguishing table. So we know that the molecularity of reactions, the definition part हमें पहले लिखना है. It is the number of atoms, ions or molecules that must collide with the one another simultaneously so as to result into a chemical reaction. तो chemical form, जो भी chemical reaction हो रहा है उसमें जितने atoms, ions और molecules involved होंगे and they are simultaneously colliding with each other, that number will be called as a molecularity. So molecularity can be unimolecular, bimolecular or a trimolecular, as we have seen in the last previous slides. Now the second is the order of reactions. So the order of reaction, you know that it is the sum of the power of concentration terms on which the rate of reactions actually depends, right? So the आपको consider करना होगा rate law. रेट लॉ में जो भी आपका concentration terms का power होगा उस power का sum will give you a order of reaction and this is only for the rate law. अगर आपके पास बैलेंस केमिकल इक्वेशन दिया गया है तो आप ऑर्डर नहीं निकाल पाओगे. यू नीड टू फर्स्ट कैलकुलेट रेट लॉ और रेट एक्सप्रेशन, उसके बाद ही आप ऑर्डर लिख सकते हो, है ना. सो मॉलिक्यूलरिटी का सेकंड पॉइंट है, मॉलिक्यूलरिटी ऑफ द रिएक्शंस कैन नेवर बी ए जीरो. इट इज नेवर पॉसिबल. अगर कोई भी रिएक्टेंट स्पीसीज इन्वॉल्व नहीं हुआ है तो रिएक्शन फर्दर होने का कोई चांस ही नहीं है, इजंट इट. सो मॉलिक्यूलरिटी ऑफ द रिएक्शंस कैन नेवर बी अ जीरो क्वांटिटी. The order of reaction can be a zero, but molecularity can never be a zero. And we know that order of reaction can have a fraction, it can have a fractional value, it can have a negative value, but molecularity is always a whole number, right? The last point, the overall molecularity of the complex reaction can be defined because, as I said earlier, कॉम्प्लेक्स रिएक्शन के लिए मॉलिक्यूलरिटी निकालना बहुत डिफिकल्ट होगा. हमें पहले देखना पड़ेगा उसमें उस जो कॉम्प्लेक्स रिएक्शन में है, जो भी कॉम्प्लेक्स रिएक्शन सेवरल स्टेप्स इन्वॉल्व कर रहा है, उसमें स्लोएस्ट स्टेप जो होगा, स्लोएस्ट स्टेप में जितने मॉलिक्यूल इन्वॉल्व होंगे, दैट विल टॉक अबाउट द मॉलिक्यूलरिटी ऑफ द गिवन रिएक्शन. द ऑर्डर ऑफ रिएक्शन इज फॉर ओवरऑल रिएक्शंस. तो ऑर्डर ऑफ रिएक्शन आप कॉम्प्लेक्स रिएक्शन के लिए भी निकाल सकते हो. यू कैन as well. So this is the simple distinguishing chart which talks about which point out the difference between the molecularity of reactions and order of reaction. Now we have already studied the how to calculate the integrated rate equations, right? So let us consider for the zero order reactions the integrated rate law निकालना है. तो हम zero order reaction के लिए क्या करेंगे? Consider a general reaction. General reactions में R is your reactant and it is forming a product P. तो हमें पता है according to the rate can be written minus dr by dt, right? और रेट लॉ के फॉर्म में कैसे लिखोगे आप? k equals to r raised to the power 0, isn't it? So this is the rate which can be written for this zero order reactions. क्योंकि इसका ऑर्डर जीरो ऑर्डर है, इसीलिए रिएक्टेंट का कॉन्सेंट्रेशन का पावर क्या होना चाहिए, जीरो. So this is the rate law I have written, a rate constant multiplied by the reactant concentration का power zero, because it is a zero order reaction which I have already considered, right? And the rate can simply rate का जनरल एक्सप्रेशन हम हमेशा लिखते हैं जब रिएक्टेंट कॉन्सेंट्रेशन के टर्म में लिखते हैं, तो वी आर ऑलवेज पुटिंग अ नेगेटिव साइन ओवर हियर. सो dr by dt equals to kr naught. Now at any quantity raised to the power 0 is unity, you know it. So this quantity will become a 1. So this ultimate rate will become rate equals to minus dr by dt equals to k into 1. So I am just simplifying this equation by writing the above equation in this manner. Dr equals to minus k dt. Now in the next step, we all know that the next step is what, derivative को हमें निकालना है, and we need to bring out the relation between a reactant concentration and a time and rate constant. So for solving this expression, we will just take an integration of both the sides. So integration of both the sides लेने के बाद क्या मिलेगा आपको, integrating both the sides between the proper limit, what you will get, integrations of dr within the limit r0 of r. This is a finite integral. When I was teaching into the regular class, I have considered as a indefinite integral. This is a definite integral. So you can write down the expression in this manner also for escaping the several steps. So it will come out, the final expression will come out in a 4 steps only. So you just put down the limit over here only, integration of r0 to r of d of r equals to minus k. Minus k being a constant, I have kept it out of the integral, and dt, integration of a dt with respect to within the limit of a 0 to t. So after solving, what you will get, this d derivative and this integration sign will get cancelled out, and you will be remaining, because integration of dr will is always r. So this will be the upper limit जब substitute करोगे, so this will become a r minus r naught equals to minus k as it is, और इसका जो इंटीग्रेशन होगा that will be a t minus 0. So 0 I am not writing over here, so this will be a minus kt. So this is the expression you have. Now ये negative sign, multiplying both the sides by the negative sign, so what you will get, instead of this it will become r0 minus r equals to kt. So finally your rate constant का expression बन जाएगा k equals to r0 minus r by t. So remember that the rate constant for the zero order reaction is dependent upon r0 minus r by t. This is the final expression for zero order reaction. Now suppose if this is the expression you have. Now I am plotting r0 minus r. So I am taking this as a concentration, change in a concentration versus a time. So change in a concentration versus time plot कैसे मिलेगा हमें, concentration onto the y axis, right, and time onto the x axis. So r naught or r0 represent the initial concentration. We know that zero order reaction होने के बाद भी reactant का product में जब conversion हो रहा है, तब initial concentration at a time t equals to 0 will be a r0, and as the time goes on my initial reactant concentration will keep on decreasing क्योंकि वो product में form कर रहा है, isn't it? We know that R is converting into the product P. It means that R का concentration हमेशा decrease होगा, है ना? तो जो overall change in the concentration will keep on decreasing when it is forming a product P. So come back to the graph. So R0 is your initial concentration, and it will keep on decreasing continuously as the time goes on, as the reaction proceeds into the forward directions, and the slope of the reaction will be a what? It will be a minus k. From the last expression, you can definitely say that if this is the change in the concentration and t, you can consider this expression as well. This is the equation of the straight line. So you can consider this equation for solving, for plotting the graph. So this is your y-axis ka coordinate, and this is the time x-axis ka coordinate, and this minus k is your slope. And intercept is found to be a what? It should be a what? It should be given in this manner if you are writing the
R naught.
equation, right? Now, integrated rate equations for the first order reaction. फर्स्ट ऑर्डर रिएक्शन के लिए भी आपको क्या करना है? नाउ कंसीडर अ वेरी सिंपल जनरल रिएक्शंस आर गिविंग योर प्रोडक्ट पी इज अ फर्स्ट ऑर्डर रिएक्शन. अब फर्स्ट ऑर्डर के लिए रेट लिखना है तो हम कैसे लिखेंगे? रेट विल बी रिटन एज माइनस डी ऑफ आर बाई डी टी इक्वल्स टू के इंटू आर. अब r का रेस टू द पावर मैंने 1 लिखा है, 1 मैंने यहाँ पर दिखाया नहीं है, बट देयर इज अ 1, राइट? Because it is a first order reaction, so what will happen? Minus dr by dt equals to k r raised to the power 1. So this is the rate expressions for a first order reaction. Now इसको थोड़ा सिंप्लीफाई करते हैं हम. d of d into r divided by r मैंने एक साइड में ला लिया, and I have kept minus k dt on another side. Now take the integration in the similar way what we have done into the previous slides, right? So after taking an integrations, what you will get? You will get a term dr by r integrations within the limit of r0 by r minus k 0 within the limit of 0 to t integration of dt. So फाइनली क्या हो जाएगा? d ऑफ r by r का इंटीग्रेशन होता है ln ऑफ r. अब मैंने अपर लिमिट सब्स्टिट्यूट कर दिया तो इट विल बिकम ln ऑफ r माइनस ln ऑफ r0 इक्वल्स टू माइनस k, एंड इसका इंटीग्रेशन क्या आता है? t, right? Now I am multiplying with the negative sign to the both the sides, so it will become a ln of r0 minus ln of r equals to kt, right? Now kt equals to ln of r0 by r, so it will become k equals to 1 by t ln of r0 by r, right? So final expressions, since it is a ln, I'm converting this quantity ln into a 2.303. So you know that ln is always, ln of anything is always equivalent to 2.303 log to the base 10. So final expression for the first order reaction is like this. So you can check once again, integration, taking an integration, substituting the upper limit and lower limit, and then simplifying the equations, the rate expression for the first order reaction becomes 2.303 by t log of r naught by r. Now we have this expression. First order के लिए हमारे पास expression ये है, right? So you can simplify the equation once again. Log of r0 by r, you can keep kt over here divided by 2.303. Now the plot of this equation. Now this expression, this is your y coordinate. लेफ्ट हैंड साइड में जो भी है log ऑफ r0 बाय r मैं ले रहा हूँ, दिस इज योर y कोऑर्डिनेट, और यहाँ पर मैं t ले रहा हूँ आपका x कोऑर्डिनेट. तो आपका टाइम t इज अ x कोऑर्डिनेट, and this total quantity onto the left hand side is considered as a y coordinate. So this will be a straight line passing through the origin, because my slope is my intercept is a 0. Intercept अगर मेरा 0 है, so the line should pass through the origin, because this is the equation of a straight line. Y equals to mx plus c. You can compare this equation with the y equals to mx plus c. So you can definitely say that if t is my x coordinate, so k upon 2.303 will be considered as a slope. So my slope will be a k upon 2.303 when you are plotting log of r0 by r versus a t. So this is the first order kinetics ka plot, which is a straight line passing through the origin. Now, up till now, what we have seen, we have studied a zero order reactions, then we have seen a first order reaction, we have calculated the integrated rate law for both the equations. Now we know that there are several reactions which do not occur in a solution case. Several reactions into the nature that occurs in a gaseous state. So gaseous state के लिए हमें अगर rate integrated rate law निकालना है तो हमें gaseous rate law consider करना पड़ेगा. तो gaseous rate law इस तरीके से consider करते हैं. Let us consider a typical first order gas phase reaction. तो typical gas phase reaction कैसे लिखोगे आप? That typical gas phase reactions can be considered as a Ag giving you a Bg plus C. Let us consider that this is a gas phase reaction, right? Now इस reactions में अगर मैं consider करूँ, this reaction can also be written in this manner. Let's say at a time t equals to 0, my initial pressure exerted by the gaseous component A is a pi atmospheric, और since the time is t equals to 0, B और C का फॉर्मेशन तो हुआ ही नहीं है, तो उसका प्रेशर क्या होगा, that will be a 0, right? Now when the reaction, this gaseous reaction has been started, my at a time t, my there will be the decrease in a pressure of A, because it is going to form simultaneously B and C gaseous component, right? So I am considering that if x atmospheric pressure be the decrease in a pressure of A at a time t, अगर वो decrease है तो कैसे होगा, when at a time t the reaction has proceeded, the final pressure of A will become a pi minus x, क्योंकि x तो डिक्रीज इन प्रेशर ऑफ A है ना, जब रिएक्शन स्टार्ट हुआ है तो मेरा जो भी प्रेशर डिक्रीज हो रहा है, दैट प्रेशर आई हैव कंसीडर्ड एज अ x, right? So the pi minus x atmosphere is the final pressure of A, right? So at the same time there is a formation of a B and C gas, so uska jo bhi pressure exert hoga, that will be x atmospheric only, right? Because x decrease hua hai to x formation bhi hoga wahan par. Now we know that pi represent the initial pressure at a time t equals to 0. Now total pressure will be the contribution from the pressure exerted by the A, pressure exerted by the B, and pressure exerted by the C. So can I just write down the expression, P total will be a PA, PB plus PC, isn't it? So here by substituting their final values, pi minus x, which is the partial pressure of A, and x is the partial pressure of a B, and another x is the partial pressure of the C. Now after solving this you will get a pi plus x, and from this expression x का value क्या मिल रहा है आपको, that is a p total minus pi. नाउ P टोटल माइनस पी आई में अब क्या करना है आपको, पी जो पार्शियल प्रेशर है यहाँ पर x की वैल्यू सब्स्टिट्यूट कर दीजिए, तो फाइनल वैल्यू मेरा क्या होगा, पी आई माइनस एक्स विल बिकम पी आई माइनस पी टी माइनस पी आई. तो पी आई विल बिकम व्हाट, इट विल बिकम अ ट्वाइस पी आई माइनस पी टी. तो याद रखिए जो पार्शियल प्रेशर आपका ए का बचता है दैट विल बी अ फाइनली 2 पी आई माइनस पी टी, राइट? एंड वी नो दैट द फर्स्ट ऑर्डर रिएक्शन के लिए रेट कांस्टेंट किस तरीके से निकाला जाता है, दैट इज k इक्वल्स टू 2.303 बाय t log ऑफ फाइनल इनिशियल प्रेशर अपॉन फाइनल प्रेशर. जैसे हम इनिशियल कॉन्सेंट्रेशन अपॉन फाइनल कॉन्सेंट्रेशन लिखते हैं उसी तरीके से इन द सिमिलर वे log of pi is the initial pressure of A and pa is the final partial pressure of a A. So the final pressure कितना निकाला आपने, that is a twice pi minus p, right? और आपके पास क्या बचा है, इनिशियल प्रेशर पी आई है. सो दिस इज द रेट एक्सप्रेशंस व्हेनेवर यू आर कंसीडरिंग अ टिपिकल फर्स्ट ऑर्डर गैस फेज रिएक्शन. जब भी गैस फेज में रिएक्शन होगा तो उसका जो रेट कांस्टेंट है वो इस एक्सप्रेशन से लिखा जाता है. तो हमेशा ध्यान में रखिए जितना भी डिक्रीज इन प्रेशर होगा उसमें से आप इनिशियल प्रेशर में से उसे माइनस कर दीजिए, एंड देन यू कैन सॉल्व द सिंपल trick. You can use this simple trick and you can calculate the remaining pressure exerted by the gaseous component A. So this is for the gaseous reaction. Now there is a very important terms which is called as a half life. You know it. Half life में मतलब क्या होता है, half life यानी it is the time required to reach the concentration, whatever the concentration is provided to you, उसका concentration exactly आधा करने के लिए, exactly half करने के लिए जो भी time हमें लग रहा है, that time is called as a half life of reaction. So half life of reaction will be defined as it is the time required in which the concentration of the reactant is reduced to one half of its initial concentration. Exactly initial concentration से उसका concentration क्या हो जाएगा, आधा. That time is called as half life. It is denoted by the symbol T half, right? So T half for a zero order reaction is what? For a zero order reactions, the rate constant is given by equation K equals to R0 minus R by T, right? So at a T equals to T half, my concentration of the reactant will become half R0. तो मेरा इनिशियल जो भी कॉन्सेंट्रेशन होगा एट पर्टिकुलर टाइम दैट विल बिकम एग्जैक्टली हाफ, बिकॉज टी हाफ का डेफिनेशन ही ये बोलता है क्या, अगर वो टाइम जिस पर आपका कॉन्सेंट्रेशन एग्जैक्टली इनिशियल कॉन्सेंट्रेशन के हाफ हो रहा है. सो कैन आई जस्ट राइट डाउन दिस इक्वेशन, ऑफ कोर्स आई कैन राइट इट डाउन दिस इक्वेशन T इक्वल्स टू T, यहाँ पर क्या होगा मेरा जो भी कॉन्सेंट्रेशन बच रहा है रिएक्टेंट का दैट शुड बी एग्जैक्टली हाफ ऑफ इट्स इनिशियल वैल्यू. So now the rate constant at a T half becomes K equals to, अब जीरो ऑर्डर रिएक्शन के लिए मुझे पता था मेरा जनरल रिएक्शन क्या था R0 माइनस R. अब R0 माइनस RT इज व्हाट, RT आपने निकाल दिया है, क्या है वो हाफ R0. तो हाफ R0 का वैल्यू सब्स्टिट्यूट करो. सो फाइनली आफ्टर सॉल्विंग दिस इक्वेशन यू विल गेट अ T half का इक्वेशन क्या मिलता है R0 by 2 की. So this is already we have solved in a great detail into the regular lecture. So T half equals to R0 by 2k is the final expression for the half-life period of a zero order reaction. Now फॉर द फर्स्ट ऑर्डर रिएक्शन के लिए कैसे निकालोगे आप? फर्स्ट ऑर्डर रिएक्शन के लिए आपको पता है रेट कांस्टेंट का एक्सप्रेशन होता है 2.303 by t log of R0 by R, राइट? तो फाइनल एक्सप्रेशन क्या बनेगा आपका k equals to 2.303 by t log of R0 by R एट t equals to t half क्या हो जाएगा आपका फाइनल कॉन्सेंट्रेशन बनेगा उसका एग्जैक्टली हाफ. नाउ सो द अबव इक्वेशन बिकम्स 2.303 by t half log of R0 और जो फाइनल कॉन्सेंट्रेशन है उसके जगह में हमको ये वैल्यू सब्स्टिट्यूट करना है. तो ये वैल्यू सब्स्टिट्यूट करके क्या मिलेगा R by 2, राइट? सो दिस विल बिकम अल्टीमेटली this expressions will become T half equals to 2.303 into log of 2 by k, क्योंकि this quantity will get cancelled out R0 by 2, this should be R0, R0 by 2, so R0 will get cancelled out and you will left with log of 2. So log of 2 का वैल्यू होता है 0.301, multiply with this factor, finally you will reach with 0.693 by k. So T half का expression for the first order reaction is a 0.693 by k. From these slides, the ultimate conclusion is what? The first order reaction, the half-life period is a constant and it is independent of the initial concentration. आप यहाँ पे देख रहे होगे, you can see it very clearly that T half के expression में कहीं पे भी initial concentration mention नहीं किया गया है. Initial concentration mention नहीं किया गया, इसका मतलब क्या है? T half is independent of the initial concentration. This is a very important relation. Several times they may ask direct questions on this, or graphical or MCQs, that T half for the first order reaction is whether it is independent or dependent on the initial concentration of the reactant. Now, there is one another reaction which is called as the pseudo first order reactions, and we know that pseudo का मतलब क्या होता है? Pseudo means झूठ-मूठ का, है ना? तो झूठ-मूठ का फर्स्ट ऑर्डर रिएक्शन, इसका मतलब क्या होता है? वो रिएक्शन आपको pseudo first order means what? That reaction is in principle after looking that reaction it seems to be a second order, but actual overall rate उसका क्या है? First order, जो होना नहीं चाहिए. So I am considering a very simple reaction. Consider reactions which are not truly of the first order, but under a certain conditions reactions becomes that of the first order are called as a pseudo unimolecular reactions, right? So pseudo unimolecular reactions consider करने के लिए a very good example is there, hydrolysis of the ester. The same example I have taken into the regular class. So hydrolysis of ester में क्या होगा? This is the ethyl methyl ester, right? So ethyl methyl esters on reaction with the H2O, it will give a acetic acid plus ethyl alcohol. Now in this reaction what happens? From this reaction the rate expression can be written in this manner. Rate कैसे लिखोगे? Rate constant into ester का concentration plus water का concentration, isn't it? तो normally rate हम इस तरीके से लिखते हैं. अब देखिए इस टोटल रिएक्शन में जो भी वाटर का कॉन्सेंट्रेशन है दैट इज वेरी वेरी लार्ज. अब यहाँ पर मैंने रिएक्शन कंडीशन क्या चेंज कर दिया? रिएक्शन कंडीशन ये चेंज किया है, जब मैं एक्सेस ऑफ वाटर लेता हूं तो एक्सेस ऑफ वाटर में क्या होता है, मेरा रिएक्शन क्या होता है? एक्सेस ऑफ वाटर के प्रेजेंस में दैट रेट will be independent of the concentration of the water. water चाहे आप कितना भी ऐड कर दो इसका रेट चेंज नहीं होगा, मगर आप अगर ईस्टर का कॉन्सेंट्रेशन 0.001 से भी चेंज करते हो तो द रेट विल चेंज. सो अल्टीमेटली यहाँ से मुझे कंक्लूजन क्या मिल रहा है? फ्रॉम दिस रिएक्शन वी आर गेटिंग दैट द ओवरऑल रेट ऑफ दिस रिएक्शन इज डिपेंडेंट अपॉन द कॉन्सेंट्रेशन ऑफ ईस्टर ओनली, क्योंकि वाटर बहुत एक्सेस में होने के कारण वो चाहे थोड़ा ऐड करो या ज्यादा ऐड करो it will not differ the rate of reaction. The rate of reaction will be a constant with respect to a water concentration because it is present in a very large amount. Now, so overall reactions will be a finally has to be a changed. So can I just write down? Therefore, rate will be a k prime into a ester concentration. अब ये k prime क्या है? K prime I have taken as concentration k, rate constant k, और जो भी concentration मेरा water का constant है, it is anyways a constant term. तो constant of concentration of water and this rate constant both are a constant. तो इन दोनों को कांस्टेंट लेके मैं एक और एक कांस्टेंट से डिनोट कर रहा हूँ, दैट इज कॉल्ड एज के प्राइम. सो के प्राइम इनटू ईस्टर. तो अब ये जो अल्टीमेट मेरा रेट बन रहा है, रेट एक्सप्रेशन, फाइनल एक्सप्रेशन बन रहा है, दिस रेट एक्सप्रेशन इज डिपेंडेंट अपॉन द ईस्टर कॉन्सेंट्रेशन ओनली. तो इनिशियली अगर आप रिएक्शन को देखते हो तो रिएक्शन को देख के ये लग रहा है हमें बायमोलिकुलर है, मगर रेट से हमें क्या पता चल रहा है? रेट से ये पता चल रहा है कि इवन इफ टू मॉलिक्यूल्स हैज बीन इन्वॉल्वड, the rate is only dependent upon the ester concentration. So in a way it is a pseudo molecular. दिखता तो बायोमोलिकुलर है, बट ओवरऑल रेट क्या है? ईस्टर के कॉन्सेंट्रेशन पर ही डिपेंडेंट है. इसीलिए दिस विल बी कॉल्ड एज अ pseudo first order reactions. You can remember this reactions, that is a hydrolysis of ester in presence of a acid. Now there is a one another example we have mentioned in a previous classes, that hydrolysis of a hydrolysis of a cane sugar is the another good example of a pseudo first order reactions, in which glucose is being hydrolyzed in presence of excess of a water. So the it will be independent of a, that reaction will be also independent of a water concentration, that will be dependent upon only the glucose concentration. So that is the another example, hydrolysis of a cane sugar. Now, there are several methods of determining the order of a reactions. So I think whatever the portion we have done, I have covered up to the pseudo first order reaction into the previous classes. So this is a quite revision. Hopefully, you people have got a good recap of this chapter. So you just keep on revising whatever the thing we have done. In the next class, maybe in a tomorrow's or the day after tomorrow's class, we'll be looking for or will be discussing about collision theory, and we'll be discussing about the temperature dependent properties or temperature dependent phenomena of rate constants and how rate is differing with the temperature. So I will stop over here for today's lectures. In the upcoming lectures we'll be talking about the collision theory and the temperature dependent phenomena of the rate of reactions. So thank you so much for concentrating. Thank you.
So unmute everyone.
Okay, sir. Thank you.
Hello.
Hello, sir. I'm listening.
Yeah, I have unmuted everyone. They can ask questions. You can ask them.
Okay, sir. So anybody having a questions, they can ask me a straightforward. Anything related to pseudo first order or rate of reactions or anything you have any doubts, you can clear it right away. Hello, Aditi. Hello.
Yes, sir.
You have any doubts up till now?
No, sir, not now.
Not now. So you don't miss the upcoming lectures. So I'll be talking about collision theory and temperature dependent property, and along with that, I'll be covering several numericals based upon
Yes,
whatever the
sir.
course we have covered.
Sir, I had one request. Like, can you please start solutions chapter after you finish this one?
Definitely. Solutions from the exercise, no?
Solutions chapter,
Oh,
chapter
okay,
number
okay, okay. You
2.
are talking about solution chapter.
Yeah.
Definitely, after only one lecture will be required for completing the collision theory and temperature dependency. and then we will immediately start with the solution chapter.
Yes.
Right?
Thank you, sir.
Okay, welcome.
Anybody has any doubts? Chaitanya, Atharva, Tanaya, Om, Geetanjali, Govin.
No, sir.
No, sir.
So
Jyoti,
hopefully you people
Kankani.
have understood this chapter, isn't it?
Yes.
Yes,
Yes,
sir.
yes.
Okay,
Yes, sir.
okay. So the speed of the lecture is good or it is very fast?
No, sir. It's
No,
okay.
it's
Good.
okay.
Good, good.
Okay, okay. Thank you.
So
Because
revise
already
everything,
we
dear
Sir.
have.
students. Revise everything. Go through the points, whatever sir has taken in detail. It was very nicely prepared, PPT, sir. I appreciate it. So
Okay, okay.
it was
So
made
I
very
can, sir,
simple to
I can
understand.
do one thing. I will forward this PPT to rest of the student. I will forward it to you. You can forward it to the all the students.
Correct, sir.
Right?
We
So
will do that.
right, right. I will give it to them.
Thank you, sir.
Thank you,
Okay,
sir.
okay. Have
Thank
a
you,
great
sir.
day. Bye, bye.
Thank you, sir. Thank you,
Thank
sir.
you, sir.
Welcome, welcome,
Thank you, sir.
Thank you, sir.
Thank
Thank you,
you.
sir.
Bye bye. Take care.
welcome.
Thank you, sir.
So thank you so much, you too.
Thank you, sir.
Anyway, sir, we should end over here. So I am
Yeah.
just ending this meeting, right?
Yes, sir. Thank you.
Okay, okay.